Hello, this is Mrs. Saunders. I'm a math teacher at Woodside High School. We're in the process of transitioning your long-term sub to another long-term sub because Mrs. Stanley is still out on maternity leave. In the meantime, I will go ahead and make videos and lessons for you through Canvas. So if you do have any questions, I'll put it in the announcements, but you can email me at jennifer.saunders@nn.k12.va.us. And again, like I said, I'll put that in your announcements so you'll know how to reach me. Your long-term sub will hopefully be able to Zoom with you at the end of this week, if not the beginning of next week for sure. All right, so let's take a look at our notes. These notes can be found on your Canvas, and you can print them out, or you can just copy this down on paper and follow along with me. So let's go ahead and begin. So it says, determine whether the relation is a function. You guys are now starting the functions portion of your semester. So you did trig last semester, and now you're doing functions. Functions is going to be a lot of Algebra 2 material. So you're going to find that a lot of this is algebra. That's preparing you for math analysis next year. In math analysis, we do trig and algebra again, and then lead into pre-calculus. And then that takes you then to calculus. So all of this kind of mushes together. So let's go ahead and get started with what is a function. So define a relation. A relation is a set of ordered pairs, x and y. Okay, a relation, x and y. The x values are the domain, the y values are the range. Now it says the definition of a function. And here's the math jargon. Given a relation in x and y, we say that y is a function of x. If for each value of x in the domain, there is exactly one value of y in the range. So it's a lot of math jargon. You might recall the x's do not repeat from your Algebra 2. If your x values don't repeat, then it's a function. If your x values do repeat, then it's not going to be a function. So now let's look at our examples here. Determine if the relation defines y as a function of x. So is it a function is what they're asking. And then find the domain and range after that. All right, so if we're looking at number 1, each ordered pair is an x and a y. Okay, so you see right here, this is an x is a 2 and this is an x is a 2. So this is not a function because the x repeats. And it repeats right here at the 2's. Now, we still have a domain in our range. The domain is going to stand for all of those x numbers, and we're going to list them out because these are dots. This isn't some long function that has lines, and it doesn't say that it's connecting. That would be if you were given an equation. So for our domain here, you can get formal with writing the domain, or you can just go ahead and list the things. We've got x is going to be a 2 and a 3. Now don't put parentheses around here because this isn't a point 2, 3. This is just the x value of 2 and the x value of 3. Now, your range, those stands for the y values, and then you just list them. You've got a 3, a 4, and a 5. Now, the reason I didn't write in the domain 2, 2, and 3 is because you already listed 2. So since you already listed 2, then you don't have to put it on there. Now, you could also look at this. What does this look like as a graph? Well, let's see. 1, 2, 3, and then we went up to 5. I didn't give myself a lot of room to go up to 5, but there, I made it. So if this is the point 2, 3, so we're 2, 3 right here. Then we have the point 2, 4, so that's right there, and then we have the point 3, 5. So that's what this thing looks like. So that's why its domain is just 2 and 3, because those are the only x values you use. Your range is 3, 4, and 5 because you used all of those y's in your graph. Now, as soon as we get down to the vertical line test, we'll come back to this one and see why it wasn't a function. Let's look at number 2. And number 2 is a function. You've got a 1, a 2, and a 3. So your x's do not repeat. So that means that, yes, this is a function. So x's do not repeat. So your domain, those are going to be your x values, 1, 2, and 3. Your range, those are going to be your y values, which is 3, up, 3, and then 5. Now notice here that our y's repeated. But we don't care if the y's repeat, not for it to be a function. We really only care if the x's repeat. Now we can plot this as well. Let's see, we got 1, 2, 3. I gave myself a little more room to get up to 5. So we have the point 1, 3. We have the point 2, 3. And then we have the point 3, 5. Okay, again, we'll come back and look at this one once we get to our vertical line test, which is next. Now let's take a look at number 3. Number 3, this is called mapping. And really all this is with mapping are these ordered pairs just in bubbles. So this -2 is going to go to this -2. This 6 is going to go to this 6. And this pi is going to go to pi. So looking here, your x's do not repeat. So since your x's don't repeat, then yes, this is a function. Now remember, pi is not a variable. Pi is just the number, 3.14159, blah, 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 blah. So it's just a number. So we don't have to worry about it being a symbol. We can just look at it as a number. So our domain is going to be our x values of -2, 6, and pi. And our range is the exact same thing, -2, 6, and pi. It's okay that they repeat because one is on the x-axis and the other one is on the y-axis. So if we were graphing this one, where you would put pi is just a little past 3. I'm not going to graph this one just because we've got these other two to take a look at. All right, so let's go on and look at the next thing. The next thing we've got is a vertical line test. Okay? A graph defines y as a function of x if no vertical line intersects the graph at more than one point. So again, remember your x values cannot repeat. So look at number 4. If you draw a vertical line anywhere in a circle, it's going to cross it over twice, which means this is not a function. Sorry, I'm getting a lot of texts during this video that I cannot answer because I can't pause this video. So they'll just have to wait. All right, let's look at number 5. Now, no matter where I draw these vertical lines, I'm only going to go through it once, which means, yes, this is a function. Now, looking at number 6, we have to zoom on in, which I don't even know if we zoom in, we can see, oh, we can. Look at number 6, we just zoomed in. That's a closed dot and that's a closed dot. Those are on top of each other. Now, if one of those had been open, we would have been okay. So, for example, if you had a closed dot and then in the same x value you had an open dot, this would be okay. But because you have two closed dots, it's not a function. Okay? This one's not a function. Let me move my video back up here, my document camera. It's not a function because the x's repeat. Okay? Now, I do want to look back up a little bit at numbers 1 and 2. Number 1 we said was not a function, but take a look. If you're doing the vertical line test, it's going to go through in 2 places at once. But look at number 2. If you go the vertical line test, it's only going to go through 1 time. So that just reiterates that number 1 is not a function because our x's repeated, and number 2 was a function because our x's did not repeat. Okay? All right, moving on to the next section. This is section 1.2. And what we're going to do is we're going to perform operations on functions. Now, they can write it a couple different ways. So they can write f plus g of x, which just means you're adding f of x plus g of x. And you're going to combine your like terms. If they have f minus g of x, you're just subtracting f of x minus g of x. Now, you do have to be careful with this one, because this negative sign is going to have to distribute if there's more than one thing in g. And then f times g, then you're just multiplying f of x times g of x. You may have to do some foiling here. Sometimes it's just distribution. And then f over g, this one's the easy one. You're just going to put f of x over g of x. Now remember, g of x cannot equal 0. If it does, then the function's undefined, because we can't have a 0 in the denominator. There are some ways to long divide and simplify f of x over g of x. At this time, we're not going to do that unless something is obviously factorable. If you could factor f of x and you can factor g of x and you could reduce the fraction, then we will. But, I don't think that we're going to see one of those today. All right, so let's look at number 1. Number 1 says evaluate f of negative 3. Now, look right above it here. You've got f of x, and now we've got f of negative 3. All you're doing is plugging a negative 3 into your function where you see the x. Now, remember when you're putting it into a function, you need to put parentheses around what you're putting in. The reason is because negative 3 without parentheses squared is going to be negative 9. But negative 3 with the parentheses squared is going to be a positive 9. And it's the positive 9 we want, because we want negative 3 times negative 3, which we know to be positive 9. Then we have a minus 3 times our negative 3 and our plus 1. So all I did was take this f of x function, and anytime I saw an x, I replaced it with a negative 3. Substitution is what it's called. Now at this point, we're going to evaluate. Now, you can do your order of operations. And typically in functions, we don't give you a calculator, but since you're at home, you do have a calculator at your disposal. So you could put it in your calculator at that point as well. I'll go ahead and do it without a calculator because this one's not very tough. Negative 3 squared is 9. A negative 3 times a negative 3 is also a plus 9. And then a plus 1. 9 plus 9 plus 1. So 9 plus 9 is 18, plus 1 is 19. So your answer for number 1 is equal to 19. Let's look at number 2. Number 2 says g of 4. So we take our g equation, and where we see x, we're going to replace it with a 4. So that's going to be the square root of 8 minus 4. Well, 8 minus 4 is 4. The square root of 4 is 2. Substitution. Now look at number 3. Number 3 is interesting. Number 3, you've got a combination of a plus 1. Well, what you're going to do is you're going to take a plus 1 and you're going to substitute it everywhere you see your x. Now remember, we're going to keep parentheses around it. So we have a plus 1 squared minus 3 times a plus 1, and then the plus 1. So this became a plus 1 with the squared, minus 3 times the a plus 1, plus the 1, plus the 1. Now, we do need to simplify this problem, which is good that we've got a little bit of room under here. Because with this, we can't just distribute the squared. A plus 1 squared is written as a plus 1 times a plus 1, which we have to FOIL. So you have to think back to FOILing. A times a is a squared. A times 1 is 1a. 1 times a is 1a, and 1 times 1 is 1. So this ends up being a squared plus 2a plus 1. Now, this negative 3 does have to distribute, so that's negative 3a minus 3, and then you need to remember to pull down that plus 1. We do have to combine our like terms. A squared does not have a like term. Positive 2a and a negative 3a is a negative 1a. You do not need the 1 there. I'm just writing it for people who need to see it. And then we have a positive 1, and a negative 3. So if you have a positive 1 minus 3, that's at negative 2. Negative 2 plus 1 is going to be a negative 1. So you end up with a squared minus a minus 1. Now, you would leave it at this. You wouldn't do anything more. We're not going to attempt to factor or do anything more with this problem. We're just simplifying. All right, let's take a look at number 4. Number 4, we have g of 10. So we're going to plug a 10 into this g function. So we have 8 minus 10. Uh-oh, that's a problem. 8, 9, 10, we get a negative 2. The square root of negative 2. Now, if we think back to Algebra 2, A negative under the radical came out as an imaginary number. So we can write that as I, the square root of negative 2. Now, if you don't remember the i's, if you're like, oh, I'm having trouble remembering those i's, we will hit these later on in another chapter. Leave it at the square root of negative 2, and know that you can't take the square root of a negative number. Okay? But the square root of negative 1 is just I, so that's where the I comes out, and the 2 stays in. Okay? All right, let's look at number 5. F minus g of negative 8. Well, that's the same as saying f of negative 8 minus g of negative 8. So we've got to plug in negative 8 into our f equation and come out with a number. Then we have to plug in negative 8 into our g equation to come out with a number. And then we subtract those values. So let's start with a negative 8 in f. So if we do this one first, we get negative 8 squared minus 3 times negative 8 plus 1. Okay? Now that one I'm going to go ahead and I'm going to put it in a calculator just so we can speed things up a little bit. So we've got, what? Negative 8 squared. Here, I'll put this over here. You can see it too. And let's get a negative in there. Haha. Not a point. Negative 8 squared minus 3 times negative 8 plus 1. That's going to give us 89. All right, so we've got 89 right here. Minus our g of negative 8. All right, so if we've got an 8 minus a negative 8, that minus is going to become a plus. So that's the square root of 16, because 8 plus 8 is 16, and the square root of 16 is 4. Well, 89 minus 4 is 85. So 85 is the answer to 5. Let's look at number 6. Number 6 said g times h of 0. So we have g of 0 times h of 0. Well, g of 0, you've got the square root of 8 minus 0, which is just the square root of 8. And h of 0, if we put that in, we've got 2 over 0 plus 1, so that's just going to be 2. And we want to multiply those. Well, if you remember, those actually can't multiply. You've got 2 the square root of 8. Now, the square root of 8 could actually be reduced a little bit. The square root of 8 comes from a 4 times a 2. So that could be 2 times 2, the square root of 2, because the square root of 4 is 2. The square root of 2 stays home. So your final answer could be 4 the square root of 2. Now again, as we're going through these, in some of these, you might have forgotten. Like you forgot about the I. You forgot about how to reduce radicals. We are going to go through sections and we are going to teach those, so you will remember how to do the square roots and how you'll do the I's. So right now in this chapter, what are we focusing on? We're focusing on these composite functions. So if you get the answer to the square root of 8, you're on the right track and we're okay. If you can reduce it even more, even better. But just know that we will come back and we will practice reducing even more at a further date. Okay? All right, let's look at number 7. Number 7 is h of negative 1. Well, look at our h. We have 2 over x plus 1. I'm going to put that over here. It's going to be 2 over negative 1 plus 1, which is 2 over 0. Well, you can't have a 0 in the denominator, which means it's just going to be undefined. You can't do it. Okay? All right, moving on to number 8. Number 8, 9, and 10. They're doing the same kinds of problems. The only difference is they've changed your equations around a little bit. So if you'd like to hit pause and you'd like to try 8, 9, and 10, I suggest it's a good time to do so. But I will continue on and work through them. So you've got r of x minus t of x. So r of x is x squared plus 3 minus t of x, which is x plus 4. Now here's the deal. Sorry for the dog distraction. You have to distribute that minus sign. You have to have parentheses because t has more than one thing. And remember, at the very beginning of all of this, I said you have to be really careful when you're doing subtraction. If your second item has more than one, you're going to have to distribute. And since this has more than one term in it, this t, we're going to have to distribute this negative sign, which lots of people do end up forgetting. So you can't forget that. So we have x squared plus 3 minus x minus 4. And then we combine our like terms. X squared and a minus x, because nothing can go with that. And a 3 minus 4 is just a minus 1. Final answer for number 8. All right, let's look at number 9. This is r of x over t of x. So we're going to put the r of x on top and the t of x on the bottom. Now, very important is that you stop. You cannot cancel those x's. Okay, if you had x plus 2 over 2, you cannot cancel those 2's because of this plus sign. So there's no canceling going on. So do not reduce, do not cancel. There's nothing you can do. You can't factor x squared plus 3, so you're just done. You're putting the r on top of the t and calling it a day, which is nice. It makes number 9 a nice, easy one. All right, number 10. We have s of x times t of x. S is 2 over x. T is x plus 4. Now, we could distribute this. Now, when you are distributing and you're multiplying fractions with fractions, just remember that everything is a fraction. That x, which wasn't as a fraction, could be x over 1. That 4, which wasn't a fraction, could be 4 over 1. And when you're multiplying fractions, top multiplies with top and bottom multiplies with bottom. So this becomes a 2x over x plus an 8 over x. Because 2 times x is 2x, 2 times 4 is 8. X times 1 is x, x times 1 is x. Now, looking here, you can reduce those x's. They can cancel out because you don't have a plus or a minus going on. You just have multiplication. So your final answer is 2 plus 8 over x. So that finishes off page 2. And now we move on to page 3. All right, page 3, compose and decompose functions. So the composition of functions. It can be written two ways. It can be written as f of g of x with that little o in the middle, or it could be f with the parentheses g of x, although we still say f of g of x. I actually prefer it written this way. This is the way I like to see it. It's the way I know how to solve the problems, because I just know that I'm putting g into f. Okay? And it doesn't matter if it's written like this, you're still putting g into f because they're done the same way. But when I see a problem like this one, I like to write it like this, just so that I know that I'm starting in the middle and I'm going to start with g of 3. It helps me to see it a little bit better than that O. Written either way, it doesn't matter, so whichever one you prefer to look at, then go with that. So in this, we do have to start in the middle, and then we have to work our way out. So we have to start with g of 3. Now this is just like what we did on this last page. You're going to plug a 3 into your g equation. So you get 5 times 3 plus 4. So that's 15 plus 4, which is 19. And then you just pull down your f. And you're finding the f of 19. Because g of 3 was 19. And now you're plugging in the 19 into the f equation. So everywhere we see x in the f equation, we're going to plug in a 19. 19 squared minus 3 times 19 plus 1. Now again, you got to think about, what am I testing here? Am I testing, can you square 19 and then multiply and add and things like that? No, I'm not testing that. What I'm testing is, do you know how to plug in 3 into the g equation and then plug that answer into your F equation. So if you're using a calculator at this point, that's fine. You can use it on your Chromebook, on your phone, or whatever it is that you want to do. You don't have to have the fancy graphing one like me. But you got the 19 squared minus 3 times 19 plus 1. It ends up with 305. Your final answer. All right, if you want to hit pause and go ahead and try this one, g of f of negative 2, starting with f of negative 2, that would be great, and I will do it in a second. All right, so we're starting with f of negative 2. So we're plugging in negative 2 into our f equation. So negative 2 squared minus 3 times negative 2 plus 1. So I'm going to plug that into my calculator. Negative 2 squared, remembering the parentheses, minus 3 times negative 2 plus 1. And you can use Desmos here too. You can plug this into Desmos. It'll give you the same kind of answer. You end up with 11. And then I pull down that g. So now I'm finding g of 11. Well, g is 5 times x plus 4. So 55 plus 4 is going to be 59. So that's number 13. That gives you your g of f of a number. Now, number 14, that changes it up a little bit. Number 14, we're doing g of f of x. So this time they didn't give us a number. They just gave us an x. Well, let's look at these. Now, with what I've given you here, with f of x and g of x, one of these ways is going to be way easier than the other way. And I'll let you determine, but you're going to find out real fast which one's the easy way and which one's the harder way. Harder just means it's got more work to it. So f of g of x means the first thing we're going to do is replace g of x with what it is. So 2x squared minus 3x plus 2. Just like up above here, we said g of 3 was 19, so we replaced g of 3 with 19. Well, this time, we don't have a number. We just have g of x. So we're going to replace it with what g of x actually is. Now, just like what we did on number 3, let's go back to number 3 over here. Number 3, we said f of a plus 1. Well, we plugged the a plus 1 into the x of every portion. We're going to plug this whole thing into the x in f. So that's going to be a 2x squared minus a 3x plus 2, and then plus the 5. Okay? Take a look. We've got x plus 5. This is our new x, and there's our plus 5. Okay? Notice that I didn't put in all this stuff in addition to the x. I replaced it. So this one went away, and this came in its spot. Okay? So there wasn't anything more added to the equation. It was just that I put it in place of. So think of it like a sticker. Okay? A substitution. Or think about a substitute teacher. For example, right now, I'm here, but your teacher's not. So if the X is the teacher's not there, but this is me. I'm more complicated. All right. Sorry. Stupid joke. So now we add things in here, like terms. And our only like terms are 5 and 2. So we end up with 2x squared minus a 3x plus a 7. That one wasn't so bad, which means that this next one's probably going to be the bad one. G of f of x, which means we're going to take f of x and we're going to put it into g. So we need to put that into g. Excuse me. F of x is x plus 5 right here, and we need to put it into g. So g has all of these x's in it. So 2 times our x plus 5 squared minus 3 times our x plus 5 plus 2. You might recall from what we did with number 3. Look at our number 3 again. We had this a plus 1 squared, which we had to FOIL. Well, look at number 14, the second part. We have this x plus 5 squared, which we have to FOIL. Now notice I didn't write that 2 twice, and I'm not gonna. That 2 is just going to distribute after I FOIL. So I have to FOIL first. So x times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. So I pull down the 2. I've got an x squared plus 10x plus 25. Now I'm going to pull down the rest of this stuff so that you can see me do it all at once. I got to distribute this 2, and then I've got to distribute this negative 3, and then I have to combine all my terms, my like terms together. So I have 2x squared plus 20x plus 50. Negative 3 distributing is a negative 3x minus 15, and then a plus 2. So I end up with 2x squared. Let's see, I have a positive 20x and a negative 3x. So that's going to be a positive 17x. Then I have a 50, and then I have a minus a 15, and I have a plus a 2. And that's going to come out to be 37. So that was my longer one. So there was the shorter way that we didn't have to FOIL, and then there was the longer way that we did have to FOIL. All right, now 15 and 16. They're very similar to number 13 and number 14. So I'd like you to pause the video and try number 15 and 16. All right, so I'm going to go over number 15 and 16. Hopefully you've paused and you've got an answer. So let's take a look. F of g of 9. So we have to start off with g of 9. So that's going to be 2 times 9 minus 8. Okay, so it's 18 minus 8, which is a 10. Okay. So f of 10, you're going to have 3 over 10 minus 4, which is going to equal 3 over 6. Which is a 1/2. So you should have the answer to be 1/2 when you're done with 15 part A. Let's look at 15 part B. 15 part B says g of f of 6. So we got to start with f of 6. So that's 3 over 6 minus 4, or 3 over 2. Then we want to do g of 3 over 2. Okay, well that's 2 times 3 over 2 minus 8, which will equal 3 minus 8, or negative 5. My paper moved on me. All right, let's take a look at number 16. Number 16. One of these is the easy way. One of these is the hard way. So let's take a look. Oh, and they already wrote them for us the way I like it. So f of g of x. So that's f of 3x squared minus 4x plus 1. So that means we're putting this into our f equation. Now remember, you're substituting it in, which means the x is gone and this long thing is in its way. It's in its place. We have to distribute our 2, 6x squared minus 8x plus 2 plus 1, and combine our like terms. So 6x squared minus 8x plus 3 should be your final answer. And that means this one should be the other one. So this is going to be g of f of x. F of x is 2x plus 1. So I have 3 times 2x plus 1 squared minus 4 times 2x plus 1 plus 1. So this I'm going to have to FOIL. 2 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And 1 times 1 is 1. The 2x plus the 2x can add together to be 4. And I'm just going to pull down the rest of this stuff before I distribute. I'm running out of space, but I'll try and squeeze it in. So I have to distribute this 3. And then I have to distribute a negative 4. And now I have to combine my like terms. So 12x squared is going to be the first thing. So I have a 12x minus an 8x. So 12x minus an 8x is a 4x. Then I have a positive 3, a negative 4, and a positive 1, which comes out to be 0. So my final answer is 12x squared plus 4x. I hope you did okay with that one. All right, moving on to our last page, 17 and 18. All right, so what we have to do with 17 and 18. 17 is just a picture, and then 18 we've got, we have a couple of things that we have to do. It's a nice little word problem. I teach calculus, and that is a great thing to kind of get you towards calculus. Okay? All right. So, let's take a look at this one. 17a. This is going to be f of 3 minus g of 3. Well, take a look over here. The blue one is your f of x, and the red one is your g of x. So if they want f of 3, they want to know, well, what's the y value when this blue equation and x is equal to 3? So you go to where x is equal to 3. There's 1, there's 2, there's 3. And you go up to the blue equation, and you see that its y value is 4. Then you want to evaluate the g equation at 3. So the g equation at 3, you see that your y value is 3. Well, 4 minus 3 is 1. So you're done. So all it is looking at your picture and determining what the y value is at the given x. So let's look at part B. This is going to be g of negative 2 over f of negative 2. Here's where x is negative 2. So our g, that's our red one. So g at negative 2 is way down here at negative 4. F of negative 2 is up here. That's our blue one. That's at a positive 2. Negative 4 over positive 2 is a negative 2. Let's look at our composite ones. So this is g of f of 1. So the first thing we have to do is figure out what the y value is of f of 1. Well, it's the blue function, remember, and f of 1, that value is equal to 2. Well, then they're just saying, okay, we'll determine then what g of 2 is. Well, the g equation is the red one, and at 2, we're all the way up there at 4. So your answer is 4. Go ahead and try D and E if you can. Hit pause and figure it out. If not, watch D and then hit pause and try E. Let's look at D. F of g of negative 3. So g is the red one. Negative 3, that's right here at negative 4. F of negative 4, alright, that's negative 4. Oh, weird, F of negative 4. I'm going to go with the end of that point right there, because look at how they stop, but they do have that arrow. So I'm going to go with negative 2 as my answer. Again, they give you the x. You're telling me what the y value is. Okay, so this is negative 1, negative 2, negative 3, negative 4, positive 1, positive 2, positive 3, positive 4. So you're giving me the y value. All right, hit pause for E. Give it a shot if you haven't already. So this one's f of negative 3. So first we have to figure out what f of negative 3 is. Well, negative 3, oh, look at that. F of negative 3, the y value is just equal to 0. And then what's that blue function at when x is equal to 0? It's right here at 2. So you get 2 as your positive answer. All right, our last one, number 18. All right, a party balloon is being filled with helium. So we're gonna think of this as a sphere, as a circle. Even though I know that balloons are kind of oblong and they're not exactly perfectly circle, we're gonna say that this is a sphere. As the balloon is filling, the radius of the balloon is changing at a rate of 3 inches per second. Write a function that represents the balloon in r of t, the radius with respect to time, after t seconds. Well, what you would do is you would take that 3 seconds and you would multiply it times time. So if the balloon had been growing for 1 second, then it would be 3 inches long. If it were growing for 2 seconds, it would be 6 inches long. If it was growing for 3 seconds, it would be 9 inches long. So every time a second goes by, it grows 3 inches. Now, for part B says, write a function that expresses the volume of a balloon, V of R, as a function of its radius, meaning we're going to have R in the equation. Now, this you probably have to look up, and I've already looked it up. It's 4/3 pi R cubed. That's the volume of a sphere. Because a balloon, we're calling it a sphere. We're calling it a nice circle. Okay? So now you just have your two equations. Now let's take a look at this one. V of R of t. So we're going to replace R of t. So we're doing the V of 3t. Well, that means that now we're going to take this 3t and we're going to put it in its R spot. So that's going to be 4/3 pi 3t cubed. Now it says, what's the meaning of this? What does that mean if you have V of 3t? Well, this is how you're going to find the volume at any time. So, for example, if I said, okay, I have been blowing up this balloon for 3 seconds. What's its volume? Well, you plug 3 into your time and you can find its volume. If I said I've been blowing up this balloon for 10 seconds, well, you plug a 10 in there and you can figure out its volume. All right, let's look at our last one. We're doing V of R of 2. Well, R of 2 is just 3 times 2, or 6. So we're finding V of 6. Well, that's 4/3 pi times 3 times 6 cubed, or 18 cubed. And what does this mean? Well, this is the volume of the balloon at 2 seconds. So essentially what we've done is we've plugged in the seconds in to find out how big it is. Okay? All right. You have a little bit of homework that is going to get you started. You won't be able to finish it. You can do the first part. The first part is going to be on all of this composite function stuff. The second part of it's on inverses, which is something you'll learn later on in the week. So your homework as a full isn't due until Sunday night at midnight. Or Monday morning, whichever one you prefer to think about. All right, again, if you have any questions, feel free to send me an email and look in your announcements because that's where you'll find everything.